All right. Has to do with the next topic, so let's call it, this is calculus with parametric equation and curves. But I want to start with a little illustration, okay? Let's say that you have a curve in the xy coordinate, but this is, well, let's say this is our starting point, and the curve is moving in a certain way like so. And some of you have already physics, and this is the starting point, so this will be x of t sub 0, and this will be y of t sub 0, okay? And here's just a generic x of t, y of t. I had the point here before on the paper, so I'm just working the point into the curve, okay? And then, what happened right there when we come to the final point? If we are looking, since we have a point at the traveling along this path, right? Then we're talking about motion, therefore we can talk about velocity. What will be the direction of the velocity vector at the end of the path? Well, it will be the direction of the tangent at this point, right? So let's assume, not assume, let's say right here you have a vector, a velocity vector, let's call it v, right? What happened is you break it down into vertical and horizontal direction. So let's say this will be v sub x, the horizontal direction of the velocity, and this will be v sub y, the vertical direction of the velocity, and this will be the resultant. So this will be just the vector. And the direction will be the following. We're going to say that v correspond to the y dx, the direction at least of the vector will be, or the velocity will be, I can define it as the y dx. Now this is really iffy a little bit because, so I'll put proportionality instead of equal. The reason is v is distance divided by time, but the y dx is distance divided by distance. So this is only the direction. So we put here the direction of the velocity vector. Okay, now, one thing I can say for certainty that v in the direction of x will be correspond to dx dt, right? Because if a point is moving, then you have a motion in the x direction, you have a motion in the y direction. And actually this is v sub x, there is no parenthesis here. This is the horizontal direction of the velocity, and v sub y will be the y dt. So, we have three quantities here. We have dy dx, which is the derivative of y with respect to x, which correspond to the slope of the tangent. This gives us the direction of where the point is going along the path. And then you have dx dt, which gives you the velocity in the x direction, and then you have dy dt, which gives you the velocity in the y direction. Tommy, was it you who asked me in the office similar question about, okay, so you can see the similarity in the answer. Now, here's the thing that how we tie this up. By the chain rule, we have the following, okay? We're going to say that dy dt, if we'll apply the chain rule, and I say that y is a function of x, then by the chain rule I can say that dy dt is dy dx times dx dt. So if I want to express dy dx in terms of dx dt and dy dt, all I need to do is solve for dy dx. What do you get? You get dy dx equals dy dt over dx dt, provided that dx dt is not equal to 0. Okay? Now this is a very important result. We're going to see the value, the benefit of this result later on.